Hello and welcome. It's your fun and friendly physics teacher, Fabs. A lot of F's and PH's in that one. So today I would like to start us on the journey of work, power, and energy, not in that specific order. In fact, we'll actually be starting with energy first. And when I talk about energy, we're going to be starting with potential, specifically gravitational potential energy right now, and kinetic energy. We will get into elastic potential energy, but that's going to wait just a little while. So we have to master those first two, gravitational potential energy and kinetic energy first. But before we start to get into all of these wonderful notes, and I give you guys some practice, first thing, I want to know what you know about work energy and power first. So if you just bear with me, we're going to go to a quick commercial break, and I will be right back. Welcome back. So what I have here on the screen and what you could see is 4 different pictures. And I would like to know 4 different pictures. We have one person. He is, let me just bring this up here so I can kind of spotlight this for you. The top person here is lifting weights. The bottom person here is just holding a weight or a brick over his head. This young lad right here is pedaling a bicycle. And Tony the Tiger and this kid, they are sliding down a hill. So I would like to know what type of energy is going on and is there work being done or not? So why don't you think about this for a second, pause this video if you need to, and I will give you a couple seconds and then we'll talk about this. Here we go. So, person lifting weights, are they doing work? What do you think? I think the answer is yes. Okay, they're trying to oppose the force of gravity to lift those weights up in order to accomplish a goal. So they are indeed doing work. This gentleman right here holding the weight over his head, do you think he is doing work? No, he is not. He is not moving that weight. He is simply just holding it over his head. Did he do work to lift it up? Yes, he did. But by just holding it, is he actually doing work? No, he is not. Okay. Now, does that weight have gravitational potential energy? Yes, it does. But does it have kinetic right now? No, it does not, because it's not moving. I realize you may be saying, whoa, yo, Fabs, hold up a little bit, man. I'm not getting this right now because we haven't talked about these energies. It's just kind of an introductory, okay? Just seeing what you know and seeing how we can relate these things together. The young man riding the bicycle here, is he doing energy? Is he doing work? Yes, he is. He's exerting energy in the form of kinetic energy to move a distance. And Tony the Tiger here with this young man, they are sliding down a hill. They are allowing all the gravitational potential energy that they had at the top of the hill to now be turned into kinetic energy. And they are moving down, and work is being done through kinetic energy. So let's cut to a quick break. We will rejoin at the board above my left-hand shoulder here, and we'll get some notes down. So I will see you guys in just 2 shakes of a lamb's tail. All right, so I'm so glad you guys can join me for these little bit of notes that we're going to be discussing. Let's try and get this board in the entire shot. There we go. All right, so let's take a little bit of time to talk about energy specifically. All right, so we talked about the intro question. We talked about who is exhibiting work and who is exhibiting energy, what types of energy. So let's dive a little bit deeper into the different types of energy and what exactly is energy. So that's the first part of our notes. What is energy? That is our big question right there. What is energy? And energy, simply stated, is the ability to do work. Okay, that's what energy is. Whether it's gravitational, whether it's elastic, whether it's chemical energy, whether it's kinetic energy, it's the ability to do work. So we're going to be specifically talking about 2 types of energy in this first set of notes. So what do you think those two types of energy are? Very good. We have gravitation, we have potential energy. And we have kinetic energy. Excellent job. And both of these energies combined give us a term that you may see, and it's called mechanical energy. All right. So mechanical energy enables an object to do work. So that is what mechanical energy is. Just think mechanical energy is really just potential and kinetic combined. I feel like a weather guy. Today we're coming through with a chance of clouds. The rain will be moving in. See? This isn't a green screen, guys. It's a real life board. Yep, even got my name on it, just so you know who I am. And so I remember who I am too. So anyway, let's get back to work. Let's dig a little bit deeper into the different types of energy, potential and kinetic. So just while we're racing, how you guys doing? How's everything going at home? You guys keeping up with your work? Make sure you get outside, stay in your yard, make sure you distance yourself from one another. Make sure you get some fresh air, okay? So enjoy it. I know it's a little cloudy out right now, but you know, the sun will poke through and it'll be beautiful out. So, all right. So let's get a little bit deeper into potential energy. Potential energy, what exactly is it? It's energy that is stored due to position. Energy that is stored due to position, okay? Let's see, what else can we write? Potential energy that is due to elevated positions is known as gravitational potential energy, and that's going to become very important because that is what we are going to be referring to this as in many of our calculations. I'm just going to put a big E for energy now. So energy, right? Energy, E, energy. Energy that is due to elevated positions, energy that is due to elevated, we're going to say height, right? Positions is known as gravitational potential energy. Gravitational PE, potential energy, right? And we actually just refer to this as GPE. GPE. All right. Well, guys, I am going to give you yet another equation to put onto our giant board of equations. I apologize. Your teacher would have been great if he could bring that board home, if he remembered to bring that board home with him, but he did not. So you're just going to have to remember these equations, make a little note card. Again, I can show you guys very quickly. Hopefully it doesn't mess with the focusing of this, but what we can do is I can very quickly remind you of our equation board. Here it is. So hopefully this focuses. If not, I'm just going to make a giant fool of myself. There we go. So quick, take a picture of that. Pause this, write everything down. There is our equation board. I realize I'm shaking quite a bit. This is a very awkward angle. So there is our equation board, and we are going to add yet another equation to that, and that is going to be our GPE equation. So GPE, in this case, will equal mass times gravity times height. Mass times gravity times height. And when I say gravity, I'm really speaking of the gravitational constant, and you all know what that is, G 9.8. So mass times gravity times height. And I'll tell you what, I will then take my handy dandy blue marker and I'll write it right up here. Oops. Or move a little bit on me. GPE equals MGH. Hopefully you guys can all see that. GPE equals MGH. All right. So let's continue our little journey. Moving on. We now need to talk about kinetic energy. So let's get the kinetic up there. So we now have kinetic energy, and what exactly is kinetic energy? Trying to open this marker, good grief. What exactly is kinetic energy? It is energy due to motion. You know that, right? Gravitational potential energy is energy that's stored, whether it's in chemical bonds, elastic materials, or height, right? GPE. Kinetic energy is the energy of motion. And that's kind of nice because there's only one equation for energy of motion, and that is just KE equals 1/2, that's a constant, mass times our velocity squared. Now, only the velocity is squared. Very, very, very important, okay? So KE equals 1/2 mv squared. That square only belongs to the v. So I know you guys are gonna have questions. I know you may make this mistake on your practice problems, but you need to understand that square only belongs to the v. You are not, let me repeat myself, you are not squaring the m. You are not squaring the 1/2. The only thing you square is the v, okay? 1/2 mv squared. And if it helps you, just put parentheses around that. Okay? That way you know the square only belongs to the v. So something else I'd like to remind you, and this will come up in later discussions, but KE also equals the net force times distance. And we'll write that as F times D. So we're not really going to concentrate on that equation right now. We're going to kind of just put it aside and rely on this equation right up on the top. Okay? So let's put that up there. KE equals 1/2 mv squared, where the square only belongs to what? The v. You are 100% correct. And what I would like to do is just talk about a couple things before I have you guys go and do some problems on this. Okay? So let's take a look at a quick practice problem. Let's say we have an eraser, and the eraser actually has a mass of 0.1 kilogram. Let's say I take that eraser from ground level and I place it on this chair right here. That is 0.75 meters up. So now it is at a height of 0.75 meters from its original height of 0 on the ground. Everything is proportional and relative to the ground. And let's see, I would like to find how much gravitational potential energy that eraser has. So what we'll do is we'll go to our gravitational potential energy equation. That equals mgh. And we'll just simply plug and chug on this. The mass is 0.1. The g is what number? 9.8, very good. And the height in this case was 0.75. And we're just going to multiply these all together. I got to get my handy dandy calculator. We multiply these all together, 0.1 times 9.8 times 0.75, and we get 0.735, 0.735. Now, the reason I did this is because I also want to give you another important piece of information, and that is the units, right? We can't have a number just be a number. We're not talking about coefficient of friction in which it's a ratio, and you remember it has to be less than 1 and there are no units. We're talking about a number value here that needs units. So what are the units for energy? And you are correct if you tell me the units for energy, they are the joule. Okay, J for joule. Again, we're not talking about the joules on your hands. What we're talking about is the energy joule, and that is spelled J-O-U-L-E. J-O-U-L-E. Some of you may pronounce this as Joel, and if we were in class right now, we can have a bunch of fun saying, oh, they're Joels, ha, 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 ha. It's more of like you kind of had to be there type thing to get it, and well, since we're not there, it's probably not that funny. So hopefully you're laughing at the awkwardness I'm displaying right now. But let's continue to move on. So we just found our gravitational potential energy. Now, let's say, different problem. Let's say we have a car, and this car is flat on the ground, and it has a mass of 500 kilograms, and it has a velocity of 10 meters per second. I want to know the KE. How much energy of motion does it possess? Let's plug it into our equation. KE equals 1/2 mv squared. 1/2 times the mass, 500, times the v squared. And please, guys, remember, the only thing that's squared here is the 10. It's the velocity. You do not square the 500. You do not square the half. So we plug this in. We're going to make sure to square our 10 first. Okay, follow your same math rules. 1/2 times 500 times 100. And then we're going to multiply through 500 times 100 equals 5,000. And then half that, you get, 50,000. And then have that, and you get 25,000. And again, those are in joules. Anytime we're measuring energy, it is in joules. Okay? So you just successfully calculated gravitational potential energy and kinetic energy. There's one more point I'd like to make before we close this video out today. That last point would be something along the lines of maybe a building, right? And here is a box. We're gonna lift this box up and put them on the top of the building. All right, so let's say the building is 80 meters tall, has a height of 80 meters, and let's say that box, for easy numbers, is 1 kilogram. Notice our units: kilograms for mass, meters for height, velocity is meters per second, energy, those are joules. So let's find the GPE. GPE equals mgh equals 1 kilogram times 9.8 times 80. This gives us a gravitational potential energy of 784 joules. All right, let's do some intuitive thinking here. So at this height of 80, and I'm going to need some different color markers for this. Let's go back to our red. Ooh, I have a brown marker. Dude, jackpot! Can't wait to use this one. Have any other colors in there? This is real life right now, guys. Ooh. I have a purple one too. I know it looks like black or blue, but it's purple. Guys, my day is made. All right, anyway, back to the important stuff, the physics. So up here, is the object moving? If it's just sitting up at the top, is it moving? I know, it's pretty simple, right? The object is not moving. So if the object has no velocity, does it have any kinetic energy? Correct. No. If there is no velocity, then 1/2 mv squared, where v is 0, the kinetic energy is 0. So up here, the Ke is equal to 0. All right, how much potential energy does it have? We just figured it out, it's 784. So up here, the GPE equals 784 joules. Now let's say some mean-spirited kid pushes this box off the ledge and it plummets, it falls down to the bottom where obviously height equals 0 down there. All right, so what is going to happen? That box will fall down, it will gain velocity until it hits the bottom. Can you guys tell me the GPE at the bottom? If the height is 0. The height is 0, h becomes 0 over there, right? So our GPE has to be 0 by default. It doesn't matter what the m and the g are. If you multiply something by 0, it's still 0. So down here, the GPE becomes 0. Ah, so what happened to our 784 joules? They were all GPE up there, but now you're telling me GPE at the bottom is 0. What happened to them? Think about this. Conversion of energy. As this box fell, it's losing height. As it loses height, it picks up velocity. And in doing so, the energy actually is converted from GPE, or gravitational potential energy, to kinetic energy. So when you have 100% of gravitational potential energy at the top and 0 kinetic energy, you have 0 gravitational potential energy at the bottom and 100% kinetic energy, because that box just fell all the way down, and right before it hit, it reached its maximum velocity, which gave us a Ke of 784 joules. And this is at the moment right before it hits the ground, right before it hits. Because I know what you're saying, oh, Mr. F, when it hit the ground, its velocity is 0. I don't know why I did that accent, I apologize. And that's very true, but we're talking about that instant, right before it hits the ground. It's like right before, it's like, marker just fell, right there, right at that instant, right before it hits the ground, okay? So that's what we're talking about. So you should understand that there's some point in here where actually the GPE equals the Ke, because you're kind of like, you're 50%, you're 50-50, okay? The point I'm trying to make with this is that given the amount of energy you start off with, that's the total amount of energy that you will have. You'll never gain or lose more. It may change from kinetic energy to potential, or potential to kinetic, and back and forth. But you'll always have that total amount of energy. And in fact, some of your problems, some of your practice problems will be like that. You know, it may be along the lines of, you have a roller coaster, and that roller coaster picks up all of its energy after the first hill. So all of its GPE up here, that's the total amount of energy we'll ever have, okay? So when it gets down here, it still has some height, that's still equaling a number, but it also has velocity now. So the kinetic energy here, the Ke and the GPE, at any point on this track, when combined, added together, will always equal the total initial energy, okay? I know it sounds a little bit confusing. I promised you, you will have some practice, and I promise you, I've already made an answer guide, an answer sheet. I will do an answer video, but I want you guys to work on those problems a little bit first before we go over those. So I hope this kind of has helped you to understand kinetic and potential energy. And the next time we meet, we will be talking, well, you'll see an answer key video, but the next time we do notes, we'll be talking about work and power. So guys, have a great day, and I will see you all in our next video. Take care, guys. Bye.